Homework 10, Quadratic Functions, Video 8. We're going to take a look at one more problem that uses the vertex of a parabola to answer something in a context. But unlike the previous one, it's not obvious this is going to be a parabola. A rancher has 80 feet of fence. She wants to build a rectangular pen adjacent to a barn. What is the maximum area she can fence in? What are the dimensions of the pen? To get this started, it would help to have a good picture. I can't draw a good picture, so I'm just going to draw a basic one. Let's pretend this is a bird's eye view of a barn. So we're looking up from above, and here's a barn. This rancher wants to build a rectangular pen adjacent to the barn. And although it doesn't explicitly state it in the instructions in the problem, I probably should have stated that she does not need to put fence along the side of the barn. The barn is serving as the fourth fence, if you will. So what we know is that we have 80 total feet of fence, and we want the maximum area. So we need to know a few things, like how to find the area of a rectangle. That's easy, length times width. But how do we even begin? The whole reason algebra came into existence, well, I take that back. One of the reasons algebra came into existence is sometimes you need to do math on things that you do not know the value of in an effort to find that value. I don't know the value of this maximum area. I don't know what the dimensions of the pen are. So I need to start by calling something some variable. In your homework, you're lucky because they already have a picture drawn and labeled for you. But in real life math, you gotta label it yourself and draw it yourself. So I need to call some dimension of this rectangle a variable. I'm just going to call this side over here x. We'll see if we can solve for x. If that side is x, because it's a rectangle, so is this one. But what should I call this third side down here? I can't call it x, I have no guarantee they're all the same. I could call it a new letter like y, but there's a piece of information I can use here. In optimization problems where you try to maximize or minimize a value, you're often given what's called a constraint. I am working under the constraint that I have only 80 feet of fence. I've already labeled two of these three sides x. So how can I label the third side? Well, I could say the third side is the 80 feet minus the two x's that I need for over here. And you can check it by adding all three of these. If you combine the like terms, all the x's would disappear, and you would get 80. So I've got something I can wrap my hands on, my mind around now. This is x, so is that. This is 80 minus 2x. But we want the maximum area, so we should probably write something to represent the area. I'm going to write something, well, let's just write area. Area is length times width. Which of these is the length, which is the width? It's a multiplication problem, it doesn't matter. So we can just say x times 80 minus 2x. What about this guy? Well, what about him? If I call this the width, it doesn't matter which one I use, and then this one's the length. So this expression would give us the area in terms of what I decided this is called. Now, this is a function. I could call it f of x, but I think I'm going to call it a of x because we're calculating area. So we have a function. We have a function that tells us, tell me how wide this pen is, and I'll calculate its area. Now, is this a parabola? Is it a quadratic function? Yeah, it is a quadratic function, even though you don't see the x squared yet. But do you see where the x squared is going to show up? If I distribute the x, I'll get 80x minus 2x squared, or when you're dealing with a quadratic function, it's almost always a good idea to put it from highest power to lowest power. So if I write the negative 2x squared and write the 80x second, the 80 is positive, so I need a plus in front of it. Now I've got something I think I can take advantage of. This is a function that tells me the area if you tell me what the width is. This is a quadratic function. The parabola opens down because of the negative 2. It will have a high point. Let's see if we can figure out what that will tell us. I'm not saying this is the correct graph, I'm just saying that it's a parabola that opens down. if we can find the vertex, remember, the y value is the function, the y is the functional value, the value that comes out of the function. So instead of calling this y, I can call it a of x. But whatever this vertex is, that should tell us how to find the maximum area, which is what we're looking for. And if we can find the vertex, it'll tell us what the width is. Remember, the x is the width that we need to set up to get that maximum area. So let's find the vertex. This function is in distinct general form. So to find the vertex, we can say x equals negative b over 2a. The b is the number in front of the x, so it's 80. So negative 80 over 2 times the a, which is negative 2. So we get negative 80 on top and negative 4 on the bottom. Negative divided by negative is positive, and 80 divided by 4 is 20. We're making progress. Let's find the y coordinate. We just have to substitute the 20 into the function. So let's go to the one down here. Negative 2 times 20 squared plus 8 times 20. Exponents first. 20 squared is 400. So we have negative 2 times 400 plus 80 times 20. Multiplication is next. Negative 2 times 400 is negative 800. 80 times 20 is 1,600. And lastly, combine them. Negative 800 plus 1,600 is 800, which means our vertex is 20, 800. What does that mean? I'm going to go back and draw the picture now of the parabola. I need to get rid of something, so unfortunately it's going to be this, but it's a video. You can pause, go back, and write it down if you need to. So what I know about this parabola is that it opens down because it was negative on the A, and the vertex is 20, 800. The x was the width, so the width is 20. The y was the area, and that's our maximum area. So here's what we know. The maximum area is 800 square feet. To get that maximum area, the width, which we call the x, has to be 20 feet. Now the question did ask for the dimensions, plural, so how do we get the length? And I apologize, way long time ago I should have written width equals length equals. And it really didn't matter which one was called width and length as long as we made a decision and ran with it. So our length is 80 minus 2x. But x was 20, so it's 80 minus 2 times 20, which is 80 minus 40, which is 40. So the answer is, if we build a 20-foot by 40-foot pen, that will use all 80 feet, 20 plus 40 plus another 20, and the biggest area we can get is 800 square feet. It does look like a lot of work to go through, but once you get the function set up, the algebra is straightforward. Go find the vertex and then interpret it in the context of the problem. You have 2 questions like this in your homework. I believe they're the last 2, but the picture's already set up for you. All you have to do is set up the function that represents an area, find the vertex, and then interpret it in the context of the problem. And that's the end of the homework 10 videos. Please let me know if you have any questions. Good luck.